And again, I would recommend, listen please, I would recommend putting your note card in order of material from earliest to latest, because it's going to go in that order for the no calculator portion and then again for the calculator portion. So for number 1A, I had some people who were thinking about, like, could I somehow make it fine using a Pythagorean identity? The answer is no. So for this one, what you would need to do is get a common denominator first. There's really not a whole lot going on beyond this that I can try to simplify. But if I start getting a common denominator, so I would give this one a 1 minus cosine x, and I would give this one a sine x. When I FOIL out the top, I end up with this for the first part. When I multiply here, that's where my sine squared x comes from. And then do you see how I highlighted the 1 at the beginning? And then this is also going to equal 1 because of the Pythagorean identity. So I have two pieces that are both equal to 1, so that's where that 2 came from. So I thought maybe if I highlighted both the 1s, it would make more sense where the 2 came from. So those two 1s added together give me the 2, and then I have my minus 2 cosine x. So I used the Pythagorean identity for what I highlighted in yellow and said, hey, this equals 1. Remember that there are multiple versions of the Pythagorean identity, right? If you go back to those notes, there's a box, and I want to say we had 9 different versions. I would write, again, just to conserve space, I would probably write only the top version of each one, because you can obtain any of the other versions by adding and subtracting and kind of manipulating things around. So I would only write the top 3 of the Pythagorean identity on your note card. Also, a friendly reminder that for Chapter 7 and Chapter 8, I think it was both of those, I found extra formula sheets. I think it was 7. Was it? Okay. And I was like, here, take these, because I know I collected them after the test, but I gave you the bonus formula sheets that I found in my drawer because I thought, oh, that might be good for you when you get to note card day. And here we are. So if you still have that Chapter 7 formula sheet, that would definitely be a good place to start. Now, once you get here, you can factor out a 2, right, a common number from both of them. And then these cancel, and you get 2 over sine x. And to be honest, I'm not sure what they would have the answer as on the answer key or what we had the answer as, but it would either be this or this. So just remembering your reciprocal buddies and what is equal to what. Is that good for the first one? Yes, no? Okay. Shh, listening. Okay, here's the second one. Remember that another strategy that you can use when you're trying to do these problems, remember we spent a bunch of days here and we were out on the board working and all that. Remember that you can also factor. So I factored by using a difference of squares. And then I knew tan squared x minus secant squared x equals 1. Or negative 1 rather. And then I took that negative 1 and multiplied it into the other parenthesis. There's nothing that this equals. There's no way to simplify this further. So even though this doesn't look like done and lovely, it is. There's nothing further that I can do. Also remember that the one benefit, again, I don't want you to think of multiple choice as like the answer is there and I will see it and it will call to me. At the same time though, remember that you do have those answer choices and you can work backwards from them too. So if you're really stuck, you might have to think about how could I work backwards to get one of these. So you could start with one that looks like a potential answer and see if you could work your way back here as well. So that is the one benefit of the multiple choice, is the idea that you can work backward and forward. But again, the backward part would be like maybe this is the solution. You don't know for sure. Okay. Okay, here is, sorry, I don't want too much on the screen because I feel like it becomes a sensory overload situation. So this one, addition and subtraction formula, this is what I I used. Could you have used different things to subtract? Yep. It doesn't matter what you use. Also, somebody said that they tried the half angle formula. Also works. So it doesn't matter what you use. You should get the same answer either way. So this is a formula I would have on my note card as well. So once I got here, I think we use S's and T's to stand for these. And so you should see that they plug into the equation, and then I can evaluate each. So the cosine at pi over 4 is root 2 over 2, because that's my x value. The cosine at pi over 3 is 1/2, because that's my x value. When I multiply those, I get root 2 over 4. So that's where that bit came from. The sine root 2 over 2, the sine root 3 over 2. When you multiply, root 6 over 4. And I could add them together because they already had a common denominator in 4. Okay. So again, the addition subtraction formulas should go on your note card too. And then 3 was the last one for today. All right, so the first note that I wrote myself was that I'm in quadrant 1, right? 15 degrees is in quadrant 1, and it's positive there, right, all the time. X's and Y's, everything's positive in quadrant 1. So this one was the half angle formula, so you kind of think backwards. So if I'm working with 15 degrees, if I take a step backwards and double it, it would have been 30. So 30 would have been the angle that I want to use, and 30 is the angle that's on my unit circle that I know something about. So again, if you don't have the unit circle memorized, that could be something else you think about, like, do I want to put it on there? And maybe not even the whole unit circle, but remember we talked about if you just put the first quadrant and think about reflecting it, so that might be helpful too. So if you're like, I don't want to budget that much room for the unit circle, well, would you want to do just the first quadrant? Maybe. So that could be something to think about. So 30 degrees we know something about. We know the cosine is root 3 over 2, so we plug that in. Then I got a common denominator. So this 1 is this 2 over 2. 2 over 2 is the same as 1, yeah? But this way they buddy up and I can actually combine them. So this becomes 2 minus root 3 all over 2. And then instead of dividing by 2, I'm going to multiply by 1/2. And so when I do that, that gives me a 4 in the denominator. This should be a 2 in the bottom, by the way. This should be a 2. Oh, let me see. Where's my dark marker so I can make it the same color? I don't know where it went. I think it's this one. This should be a 2 in the bottom right here. Because to get from this step to this step, we square rooted. And what do we know the square root of 4 is? 2. So this should be a 2. In the numerator, you should have the square root of 2 minus root 3. So this right here looks not the best. That is a 2. Good? And that's why the square root's no longer around the bottom, because I actively took the square root of the denominator. What questions do you have for me on this first part? I'm going to leave this whole thing up here. So if you're still writing,